Hello everyone, I'm Fahad Alom, an engineer, designer, and founder of Off2Dose, where we blend science, tech, and creativity to solve real-world problems. Today, I'm here to take you deep into the world of UAVs and how they're reshaping the future of engineering and beyond. First, I'd like to talk about photogrammetry. Drone photogrammetry is the art and science of turning photos into 3D reality. Highly accurate and photorealistic 3D representations of land, buildings, and structures. We can extract orthomosaics, digital elevation models, and even generate contour lines. Photogrammetry is the science and technique of extracting precise measurements and 3D information from photographs. By capturing a series of overlapping images from different angles, typically using drones, handheld cameras, or satellites, software can reconstruct the shape, size, and spatial position of objects or landscapes. This process works by identifying common visual features across multiple photos and triangulating their positions in 3D space, resulting in outputs like point clouds, textured meshes, orthomosaics, and digital elevation models, widely used in surveying, architecture, archaeology, and game development. Photogrammetry transforms flat images into accurate, measurable, and immersive 3D representations of the real world. Let's explore how drones are transforming surveying and mapping. Using high-resolution cameras and GPS, drones fly autonomously to collect precise geospatial data from above. These surveys help us map land, measure volumes, and analyze terrain, all with incredible speed and accuracy. The most common drone survey types include topographic mapping for terrain modeling, cadastral surveys for property boundaries, volumetric analysis for mining or construction sites, and corridor mapping for roads, railways, and pipelines. The process begins with flight planning using software like Drone Deploy or DJI Pro. We define altitude, overlap, and grid patterns. Next, ground control points, or GCPs, are placed on the ground and surveyed using GNSS devices for centimeter-level accuracy. The drone flies autonomously and captures hundreds of overlapping images. Later, we process them into maps and 3D models using tools like Pix4D or Agasoft Metashape. This technology is now being used in Bangladesh to manage river encroachments, monitor construction, and even plan flood defenses. Now let's dive into two powerful accuracy tools, RTK and PPK. RTK, or real-time kinematic, corrects GPS data instantly by communicating with a ground station or satellite network. It's perfect for live applications like construction stakeouts or small area precision mapping. PPK, or post-processed kinematic, records GPS data during flight and applies corrections afterward. It's more resilient in areas with weak signal and is ideal for long-distance or remote missions. Both technologies deliver sub-centimeter accuracy when used properly, especially with well-surveyed GCPs. In practical terms, RTK is fast, while PPK is more flexible. Together, they're raising the standard for drone mapping worldwide, and they're just beginning to gain traction in Bangladesh. Last but not least, drones in infrastructure inspection. Traditionally, inspecting bridges, roads, or power lines was dangerous and time-consuming. Now, drones make it safer, faster, and smarter. Using high-res RGB cameras, drones can spot cracks, rust, or wear in roads and bridges. Thermal cameras detect heat anomalies in electrical lines or transformers. LiDAR sensors can reveal structural deformations with millimeter precision. With AI, we can automate damage detection, categorize risk levels, and generate instant reports.